So let's say that we have y is equal to the secant of 3 pi over 2 minus x. And what we want to do is we want to figure out what dy dx is, the derivative of y with respect to x is, at x equal pi over 4. And like always, pause this video and see if you could figure it out. Well, as you can see here, we have a composite function. We're taking the secant not just of x, but you could view this as of another expression that I guess you could define, or as of another function. So for example, if we call this right over here u of x, so let's do that. So if we say u of x is equal to 3 pi over 2 minus x, and we could also figure out u prime of x is going to be equal to derivative of 3 pi over 2, that's just going to be 0. Derivative of minus x, well, that's just going to be minus 1. And you could just view that as a power rule. It's 1 times negative 1 times x to the 0 power, which is just 1. So there you go. So we could view this as the derivative of secant with respect to u of x. And when we take the derivative of secant with respect to u of x times the derivative of u with respect to x. And you might say, well, what about the derivative of secant? Well, in other videos, we actually prove it out. And you could actually rederive it. Secant is just 1 over cosine of x, so it comes straight out of the chain rule. So in other videos, we prove that the derivative of the secant of x, is equal to sine of x over cosine of x over cosine of x squared. So if we're trying to find the derivative of y with respect to x, well, it's going to be the derivative of secant with respect to u of x times the derivative of u with respect to x. So let's do that. The derivative of secant with respect to u of x, well, instead of seeing an x everywhere, you're going to see a u of x everywhere. So this is going to be sine of u of x, and I don't have to write u of x. I could write 3 pi over 2 minus x, but I'll write u of x right over here just to really visualize what we're doing. So sine of u of x over cosine squared of u of x. Cosine squared. Let me do those parentheses in the blue color just to make sure that you identify it with the trig function. So cosine squared of u of x. So that's the derivative of secant with respect to u of x. And then the chain rule tells us it's going to be that times u prime of x. So what is this going to be equal to? Well, I could just substitute back. This is going to be equal to, I will write it like this, sine of u of x, which is 3 pi over 2 minus x, and I'll fill that in a second, over cosine of u of x squared times u prime of x. U of x is 3 pi over 2 minus x, 3 pi over 2 minus x. And then u prime of x, we already figured out, is negative 1. So I could write times negative 1. Well, yeah, let me just leave it out there for now. I could have just put a negative out front, but I really want you to be able to see what I'm doing here. And now we want to evaluate at x equals pi over 4. So when that is equal to pi over 4. So let's see, this is going to be equal to sine of, what's 3 pi over 2 minus pi over 4? I'll do that over here. So if you have a common denominator, that is 6 pi over 4. That's the same thing as 3 pi over 2 minus pi over 4. Minus pi over 4 is equal to 5 pi over 4. So it's sine of 5 pi over 4. 5 pi over 4 over cosine squared of 5 pi over 4, and then times negative 1. And I could just put that out here. Now, what is sine of 5 pi over 4 and cosine squared of 5 pi over 4? Well, I don't have that memorized, but let's actually draw a unit circle, and we should be able to figure out what that is. So a unit circle, I try to hand draw it as best as I can. Please forgive me that this circle does not look really like a circle. All right. Okay. So let me just remember my angles. So I in my brain, I sometimes convert into degrees. Pi over 4 is 45 degrees. This is pi over 2. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. Lands you right over there. So if you wanted to see where you intersect the unit circle, this is at the point. This is at the point. Your x-coordinate is negative square root of 2 over 2. Negative square root of 2 over 2. And your y-coordinate is negative square root of 2 over 2. If you're wondering how I got that, I encourage you to review the unit circle and some of the standard angles around the unit circle. You'll see that in the trigonometry section of Khan Academy. But this is enough for us because the sine is the y-coordinate. It's the y-coordinate here. So negative square root of 2 over 2. So this is negative square root of 2 over 2. And then the cosine is the x-coordinate, which is also negative square root of 2 over 2, but it's going to be that squared. Negative square root of 2 over 2, we're squaring it. So if we square this, it's going to become, it's going to become positive. And then square root of 2 squared is 2, and then 2 squared is 4. So it's 1/2. So this is, the denominator is equal to 1/2. See, in the numerator, this negative cancels out with that negative. And so we are left with, and we deserve a little bit of a drum roll, that we are left with square root of 2 over 2, that's the numerator, divided by 1/2. Well, that's the same thing as multiplying by 2. So we are left with positive square root of 2 is the slope of the tangent line to the graph of y is equal to this when x is equal to pi over 4. Pretty exciting.